Losses of pre-stress. Losses of pre-stress in the PSC member. Okay. So there are one, two, three, four, five, six losses are the major losses in the pre-stress concrete. Okay. So first one is losses due to pre-stress due to elastic deformation of concrete. Then second one losses due to shrinkage, losses due to creep, losses due to relaxation, losses due to anchor slip, losses due to friction. So in that first one, I will go for losses due to preset due to elastic deformation of the concrete. So this is the diagram in which the pre-stressing is applied to the both ends of the beam. So this losses due to pre-stress is given by M into Fc, where M is the modular ratio, ES and EC that is given by ES and EC, where ES is equal to 2 or 2 into 2.1 into 10 raised to 5 Newton per mm square, and AC is 5700 root of FCK, where FCC strength of the concrete. It is available in the page number 16 of IS code 1343. So where FC is the stress in the concrete at the level of the steel. So in the post-tension PSC beam, if the number of cables are pulled simultaneously, then there is a no loss. Then if the cables are pulled one by one, then there will be loss in the pre-stress. Therefore loss is equal to M into FC. So second one is loss due to shrinkage of the concrete, that is given by sinker strain into ES, where sinker strain is equal to 0.003 for pre-tension, that is equal to 0.002 divided by log 10 T plus 2 for post-tension members, where T is the age of the concrete that they transfer in the days. So next one is C, losses due to creep. Creep is a long-term deflection due to the constant load. So using creep coefficient, loss is equal to pi into Fc into m Newton per mm square, where pi is the creep coefficient as per the IS code book 1343, page number 17. Using ultimate creep strain, loss is equal to ECC ES Fc into ES Newton per mm square, where ECS is the ultimate creep strain. Then loss due to relaxation, so that is given by percentage of initial pre-stress. Okay, then loss due to anchor slip. Okay, that is given by loss delta into ES upon L. We know that delta is equal to PL upon AE. P upon A is nothing but stress, L upon E remains same there. Therefore delta is the amount of slip in mm, L is the length of the span of the beam. Last one is losses due to friction. When this is available for the only post tension beams, so that is given by Px is called P naught e raised to minus mu into alpha plus k into x, where P naught is the initial pre-stress, mu is the coefficient of friction, then k is the wave effect or Obel effect, then alpha is the cumulative angle, and x is the distance. The coefficient of friction 0.555 concrete, 0.30 for steel, and 0.25 for lead. So wave or wave effect or Hubble effect is given by 15 to 10 raised to minus 4 for p-tension and 15 to 10 raised to minus 4 per meter for report tension members. Therefore, lastly, Px is equal to P naught 1 minus mu into alpha plus k into x. Therefore, finally, losses is given by P naught into mu into alpha plus k into x. So note, if the cable is pulled, so you know that the cables can be pulled in two ends. If the cable is pulled in one end, then here we are having the slope that is given by 4a upon L. Okay, alpha is equal to 2 into slope, and x will be L. If the cable is pulled in both ends, then slope will be 2 upon L. Before it was 4 upon L, and now it is 2 upon L. For linear, it is for linear cable, then alpha is equal to slope here in previous it was 2 into slope, and x is equal to L in previously, and then x is equal to 1 by 2. So this is one typical example. So a pre-tense concrete beam 200 by 300 mm span 6 meters cemented pre-stressed by a force of 400 kilonewton applied to a constant eccentricity of 70 mm by both the tendons of by 70 mm by tendons of an area of 4,400 mm square. If ES is given and DC is given, creep coefficient is given, shrinkage is given, and stress, relaxation of stress is given, find the percentage loss in the steel of the tendon. So this is the diagram. Then the E is the E value is the 17, length is 6 meters, and breadth is 200 and 300. P is 400 kilonewton. RF cable 400 square. So loss due to elastic deformation loss is called diamond FC. Therefore M is called modulus ESF on the C, that is called 6.06. FC is called toe stress in the concrete, the level of the steel. Similarly, area is there 200 into 316 10 to Q. I is equal to 200 10 divided by 12. So Fc is equal to 111.0 Newton for loss square minute Fc. Similarly, loss due to shrinkage, loss ES upon ECS upon ES. So loss due to creep is equal to 5 into Fc into M. So that is given by loss due to initial phase stress, that is called force upon area. Similarly, therefore, loss is the percentage of initial pre-stress. The loss is got 3 divided by 100 into 1000, 30 Newton per mm. Therefore, total loss is got all of the above losses, that is 66.1340 plus 132.24 plus 30. So 268.37 Newton. The percentage loss is total loss divided by initial pre-stress, that into 100. So that is nothing but 26.8%. Similarly, these are the other examples which have been solved. If you have any doubt, you can ask. These are very simple examples. Okay, thank you.